Welcome, pre-AP, to the continuation of the average atomic mass lecture. Before we get started, copy down this new equation. Press pause if you need to. Just to review yesterday a tad, it's not weird. They think it's weird. There's basically three parts to all of our average atomic mass problems that we dealt with. All right, you've got your isotopes, the masses. You've got the percentages that were given to you, and then you use those to find the average atomic mass, the decimal number that was on your periodic table. The second half of this lecture is the exact same stuff, but with a different missing variable for you to find. Instead of giving you the percentages, I'm going to give you the average atomic mass. And what that does is make you find the percentages, which is a little different, using this equation instead. Usually students think it's a little more challenging, but hopefully after the first one where things start off a little rocky, I think you'll be just fine. So let's take a look at what our problem is. Pause the video and write down this problem. So what we have here are a couple examples of europium. It should look very similar to what yesterday looked like. Make sure you have that equation that you wrote down in front of your eyes, because I'm going to be referring to it like it's still posted. So here's what I know right away about europium. It tells me that there are two europium isotopes. All right? One of them have a mass of 151. While the other one has a mass of 153. What I don't know are the percentages. What percentage do each of them exist in nature? If you take a look at that new equation, I'm going to go piece by piece to identify what needs to go in each spot. So the first thing that you see in the equation is isotope mass 1. Now, if you look at this problem, not only does it tell you europium 151, but it gives you a more specific mass also. At any point in time in this class, when you're given two different values that represent the same thing, always use the more specific, the more precise number between the two, if given the option. So I'm going to use the number, you're writing with me, 150.9196 as the very first isotope in the problem. What's in the next set of parentheses in the equation? There's an X. Hey, you see that X right there? That's the answer to the problem. That's what we're trying to find. That X is the percent abundance of europium 151. We're not ready to find it yet, but that's why the X is there. You'll then see a plus sign in the equation. And it says isotope 2. If you take a look up there, isotope 2 has a mass of 152.9209. What does it say we're multiplying him times? 1 minus x is a part of your equation. 1 minus x. And then it says AAM. What does AAM stand for? Average atomic mass. If you didn't know that, make a note so you don't have a random acronym in your notes. AAM stands for average atomic mass, what we've been studying for 2 days. And it's given to us in the problem, 151.96. Everybody okay so far? All I did was put information into your new equation. The next step is to start simplifying. All right, and really, guys, chemistry ends right here, and it's just algebra to get to an answer. Algebra is actually a prereq for my course. Bless you. Haha, see, you did it. You're on there. So I kind of expect you to be able to do the rest without my help. Of course, I'm going to help you, and I want you to ask questions, but I really hope that this at least looks familiar. So let's start simplifying. I see multiplication here. A number times x is that number x. So I'm going to get 150.9196 x as I simplify that first part. Plus, hey, there's a different mathematical property in the next section. What's that one called? The distributive. The distributive property says that I want to multiply this number times that guy, and then again times that guy. So let's do it. Him times 1 is him. 152.9209. Cool. Again, him times minus x is minus him x. And we haven't done anything to the average atomic mass yet, so cool. Is everybody okay with what I've done so far? You've got to speak up if not. Anybody know the name of the next step looking at my algebra? Combine like terms. I see a couple like terms. I see one with x, see my two terms with x, and then I see two terms without an x. And I can combine each of those. Let's do the x first. Hey, look, my two x terms are on the same side of the equal sign. That means it's very straightforward. You should just do whatever it says they're doing. And here's what I mean. It looks like it says that x minus that one. Are you with me? All right, so I'm going to just move it over so you can see it. But all I'm doing is combining the x's by saying him minus him is going to go just like this. I'm not going to solve it yet, but that's what it looks like. But now I've got my two non-x's, and they're on different sides of the equal sign, which is a little different. In order to move him to the other side of the equality, well, I've got to do the opposite of that. What's the opposite of addition? Yeah, if I subtract this non-x expression, it'll make him disappear from that side, and I can move him to the other side, because whatever you do to one side, you've got to do to the other. So now I've got these two expressions to solve. All right? Don't do what I'm doing with the red right here, but he's already kind of gone because by subtracting him, he disappeared from that side. And he's not even really there either because I just kind of moved him over there so you could see the arithmetic that you're doing. So all we're really left with is this equals this. And use your calculator. There's no reason to longhand it. 150.9196 minus 152.9209. I get negative 2.0013 x. Make sure you're okay with my red number. On the other side of the equality is this guy. Does anybody have that value? I haven't found it. Negative 0.96 what? 09. That looks good. How do I isolate the x? Divide. You do the opposite of whatever he's currently doing. He's currently multiplying. So if I divide by this same number that he's connected to, it'll get him by himself. But I've got to do it to both sides. And this is what will get us to our percentage. So type it in and let's see where we land. And hopefully your calculator screen looks something like this. Yeah? Here's the interesting thing. That is X. That is the answer. It's the percentage we're looking for the first isotope. However, we know from yesterday that only decimal numbers can go into these equations, which means only decimal numbers are going to be spit out. I want a percent abundance, not a decimal abundance, which means he needs to be changed, but you already know how to do it. It's a little backwards, though. How do I turn him into a percentage? Let's slide him to the right this time instead of the left, and that will be an answer. I get 48.01% of europium-151. I need the percentage of the other isotope. However, we don't have to do any mathematical madness to get there, because I know that this number plus this number should be 100%, right? So then what's that number? Not 52. Yeah, if you just subtract 100 minus the percentage you found, you'll find the other percentage. And now we have completed the entire problem. Write down our second example. Pause the video. Let's start from scratch on this antimony problem, and hopefully everything starts to click in your brain. Have the equation in front of you, starting with isotope mass 1. I see 120.904. My equation says that will multiply by X. And then be added to the second isotope listed, which looks like it's 122.904. And that multiplies times 1 minus X. And equals the given average atomic mass, which is at 121.76. Please do not suffer in silence. Are there any questions about the information I've put up there so far? Let's simplify then. That number times X is that number X. Plus distribute this number times 1 is this number. Minus this number times X, which will be this number again with an X on it. And the 121.76 will hang out for another section. Any green questions? Oh, y'all are killer quiet. We're sure we're all good. Let's combine like terms. I see an X here and an X there. Let's put them together. This X minus that X. Let's bring it over here so we can see it. There it is. Combine the other like terms, no x and no x. They're on different sides of the equality, so we can move him over by subtracting. That'll get rid of them on that side, but I've got to do the same thing over here. Any questions on the red? All right. Let's do some arithmetic on our calculator. This minus this is negative 2x. Does anybody have the other one? I didn't type it in. Like that? Isolate the x by dividing by the number connected to the x. Now it's antimony that we're dealing with, all right, and we've got antimony 121 and 123. And we're trying to find out the percent abundance of each of them. This calculation right here makes my calculator say 0.572. Of course, that's a decimal version of my answer. Slide to the right twice to get the actual answer. Antimony 121 is abundant 57.2% of the time. This percentage plus the missing percentage must be 100%, so we can easily deduce the other percentage. 42.8, I believe. Write down our last example, pause the video. We'll start off by having somebody read the top line to me on just putting it into the equation. Let's go 1-1. It takes on you a lot. This is the only class that does that in too. Okay. Just read to me what you initially wrote. Everybody cool with the green info? I like it too. Good job. Let's do the next color with somebody. Let's go 5-2. Oh, that's where you were. It tried to find you. You got lucky. Let's go down here. 5-6. 3-6. Yay! Simplify. Just start your simplification process.
I go at 94.08x plus 96.102 minus 96.102 equals 95.96.
We okay with the red? All right, let's simplify then. I want to put the x's together. This minus this looks like this. All right, I want to put the other guys together. This over to there. Well, I need to subtract it to get it there. Both sides. right. I want somebody's answers. We're going to go 4-1. What did you get as an answer to this guy here?
Negative 1.9.
X, right? Everybody okay with that maroon number? Y'all are brilliant. All right, what about the other one?
Negative 0.14.
We okay everywhere? Divide both of them by the number connected to the X. Both sides. We are dealing with a couple MOs, MO 95 and 96. Let's check out some answers. We're going to go 3-5. What did you get for the, already have the decimal move. What did you get for the percent abundance of MO 95?
11.8%.
I get 11.9% if you round better. All right, it's at 11.89 is what your calculator said, so it bumped it up. What did you get for the other percentage? Perfect. Hey, you adjusted. I like it. Are we okay with the answers? Don't put your stuff away. I want to pick on one more person. 5-1. Hey, look at these percentages, and now look at the periodic table. Steal one. And tell me if this information supports what that says the most common isotope of molybdenum is. Kind of in the middle, maybe a tad to the left middle. So does that common isotope support this data? In other words, round the number and compare it to what this says the most common is. So you read the decimal number to me. You said it was 95.96, right? What does that round to? A whole number. What does it round to? 96. Does this say that 96 is the most common isotope? It does, by 88% of the time. My point being that the data should all support each other.